I have a lot of tutorials with visual effects and games that use a colored marker like this as the input. Today I'm going to teach you a new way of detecting this, a simpler one, and I think it's even more reliable, but only time will tell, really. And I'll also show you how to detect two markers so we can use them for the steering in the racing game later. This method could actually be extended to have as many markers as you want. Like the video where I coded the real-time avatar could have used a version of this instead. There, 5 markers were needed to get the head position and the facial gestures. But today, we'll make it work with just 2 markers and leave generalizing it for some other time. Now, open your code editor and get ready to mark down the details. Get it? Mark down because the marker is no, no, no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
I have Visual Studio Code open in this empty folder. And let's create our index.html file here and start with basic HTML, the doc type, the HTML tag, the head tag, and the title is going to be marker detector. Let's add the space here as well. Now the body is going to have a video element this time. We're going to start by showing the webcam feed on a video element. Let's save and open index.html in a browser. I'm using Google Chrome. You can see the title appears here at the top. And if you open the developer tools, you can see the video element is also there, but transparent, so we can see it. Let's add a style for it. Here in the head section, in the style tag, I will add for videos a border, a 2-pixel border and solid. It defaults to black. And if you refresh, it's going to look like this now. And to make it show the camera, we have to access it in JavaScript. I'm going to give an ID of my video to this element. And here, let's begin typing our JavaScript code in a script tag. We'll access it by using the navigator media devices and calling getUserMedia. Now, here we're going to specify that we want the video only, so video set to true. And this returns a promise. So we need to type here then. We have a callback function where we can access this raw data. This is the raw data from the webcam. And let's close our callback function like so, and remember this parenthesis. And inside we can set the video source object to this raw data like this and tell the video to play. Now it's good at this point to also go here and catch in case there is some error, like maybe the camera doesn't exist or the user didn't allow to use the camera. And in that case, we are going to just alert this error so user knows that something is wrong. Now, if we save and refresh, there are 2 me's there now, and this is kind of confusing. I don't know where to look. So I just make the camera go down here for the rest of the video, and we will start using these markers at some point and try to detect them. To do image processing like that, we need to use the canvas element. We can't just process on this video element like that. So I'm going to define a canvas element like this. And this would be transparent as well. So let's give it a similar style as the video here, canvas, and then let's make this border blue. Save and refresh. And this is what we get. The canvas is now here below or to the side if there's enough space, but it's not the right size. To set it the right size, we have to go here after the video has loaded and take the metadata from it. We do that by using onloaded data, and then in the callback function, we can set the canvas width to that of the video width. And we do the same thing with the canvas height and the video height. Save and refresh. And you see now they're the same size, but let's put the image there as well. So we need to draw on the canvas for that. And I'm going to go here and say CTX is my canvas, get context 2D. We use the context to draw on the canvas. And here we can say draw image, my video, starting at 0, 0, so the top left corner of the canvas, we say my canvas width and my canvas height. This should cover it. And now if you save and refresh, it kind of works, but it doesn't. Like I'm moving my hand in this video here, but this stays stuck to the first frame. We need to loop and do this draw image on every frame. So let's implement the function for that and begin the loop here. I'm just going to define it here at the top, and all it does is this thing. Like so. And it needs to call itself. We use request animation frame for that, and let's pass here loop. So this is going to call loop again and again and again, many times per second. It's going to try to do it 60 times per second. And now if you save and refresh, then both of them are in sync. And we don't really need this one right here. It doesn't need to be even added to the DOM. We could, for example, define it like this, just in JavaScript as a global variable. And now if you save and refresh, you can see it's just the canvas here, the one with the blue border. And it's time to start to do some image processing on this canvas. To do that, we first get the image data after we drew the video on it. So image data, we use the context to get image data, starting at 0, 0, and the full size of the canvas. We want everything here. And now I'm going to call here the debugger so that we can investigate this object a little bit. Save, refresh. And now if you open the developer tools in the sources here, you can see that it stopped at the debugger and the image is actually stuck now. I'm moving my hand, but you don't see it moving there. You could see it moving a little bit if I press now this play multiple times. You see that the image is not there and moving every time we press this, it's going to refresh there. But I wanted to stop so that we can look a little bit at this image data object here. So sRGB color space, the width and height, these are important. And we're going to use them soon. And also the data, it's a long array, a really long array with the size, the width times the height times 4. Because each value here, each group of 4 values represents one single pixel, starting with this top left corner pixel and moving like that, row by row, until the bottom it contains the information for all of them in groups of 4. This is the red amount, green, blue amount, and then this is the opacity. All of them are maximum here, so 255 is the maximum value for all of these. And you'll see this 255 on every 4th item in this array because our camera doesn't support transparency. Now this color here, red, green, blue, they are kind of equal. That means this first pixel is actually a kind of a gray pixel. And just above my wristband here, there seem to be some gray items there. But let's see what happens if I'm gonna move one of these markers in that corner. Let's see. I'm gonna try to have an image with it there. Okay, and now let's inspect this image data again. And the first pixel should be blue. And there is a lot of blue there, 200, but it's not maximum. And you can see some other things there as well, a little bit of red and quite a lot of green, really. Even though this looks blue and it's supposed to be a blue whiteboard marker, it doesn't look blue to the computer. There are many things that can change this, some noise in the sensor or reflections in the cap, because it's kind of like a mirror. Like if my shirt reflects on it or something else in this room, it is going to add some values for those things. We'll need our method to tolerate things like that and just say that this is blue because there's a lot of blue compared to these other things. So let's do that. Let's implement this blue marker detector. It's going to work with this image data. And when we have it, we can say something like marker detector detect on the image data. And it's going to be a global variable. I'm going to define it here at the top. It's a new marker detector. And we implement this in its own file. So here above the script tag, let's include a new file like so. And if you control click this, Visual Studio Code creates the file for you. And now we can start typing the marker detector code. We'll do that by typing a class with an empty constructor for now. And let's give it that detect method with the image data parameter. And let's loop through that array, that ImageData.data array, like so. And we're increasing here by 4 because I want to go pixel by pixel. Now I like to take out the red value of the pixel, like so. And we can do the same for the green and for the blue, but we have to add here +1 and +2. And this is essentially +0. I don't usually add it, but if you do, they align nicely like this. And now it's time to measure the blueness somehow. And I'm just going to put the formula here that makes sense to me and seems to work in practice as well. It's going to be B minus the max of R and G. We're really interested in the maximum because the closer the maximum is to B, the less blue something appears to be. Like if red is really high, then it's kind of purple. And if green is really high, then it's some greenish cyan-like color. But anyway, the bigger the difference here, the more blueness we can expect. And let's debug here a little bit. I'm going to add all these blueness values into an array called points. And at the top here, let's define the points like this. And let's call the debugger here now to see how they get populated. Now if we save and refresh, you can see the debugger is here now and the points are empty. But as we go line by line here, we get our first blueness value of -7 apparently. So looks like in the beginning it's still that small part there with gray, and it just happens to be a little bit less blue than other colors there. And we can continue like this and debug each line if we want. So the second value is going to be -7, -7. So many small pixels there seem to have the same blueness. And this array starts to have 3 items now. Let's try one more, -6 this time. And we can continue. I'm going to add the breakpoint here at the end. And let's go all the way there now. And the points array is now complete. It starts with those 4 values we saw earlier, and then we see a lot of other things as well. I don't see this blue area, and it's going to be almost impossible to find just by clicking here randomly like that. Or we might have found it accidentally here. I think I was in luck, stumbled upon a place where there are these blue pixels from the marker. So it does seem like it holds the data that we expect. Now, what we'll do is we'll keep just the positive values. We don't care if the blueness is negative. It's definitely not something we want. And let's debug this a little bit nicer next. So here I'm only going to push those values if they are positive. And I also want to know where those points are, like the X and Y value inside of this ImageData array. We'll first get the pixel index by just dividing I by 4 here. And then let's calculate the Y coordinate. It's going to be p index divided by the width of the image data. But this is going to give us a floating point number, most likely. And we don't want that because pixels have integer values there. So here I'm going to say the floor of that value. And then the x is again dividing the p index by the image data width, but here we use the modulo operator so that we keep just the remainder, that extra value there on the last line. And now we can pass to these points not just the blueness value, I think that's still useful to have there, but also let's wrap it in an object and say x and the y and the blueness value and close the object like this. Now the points don't only have the blueness value, but it also stores where on the screen that blueness value exists. So we are going to use this to debug nicer. And I'm going to create here a temporary canvas for debugging inside of this marker editor. So let's ask the document to create a canvas element like this. And let's get the context for drawing on this one. And I'm going to add it to the document body like this so that we see it there. Otherwise, it's in memory like our video from earlier. And at the bottom of this detect method here, we're going to have this debugging section where I'm first going to tell the canvas how big it should be based on the image data width and image data height. And now we're going to loop through all those points we calculated earlier. I'm going to ask the context to fill a rect at that location and a small point, just coloring that pixel basically. So 1 and 1 for the width and height. Now let's save this and refresh. And this is what we get. These are all the pixels where the blueness is non-zero. Some of them make sense, like my wristband here is blue, and of course the markers have blue in them, the caps, and then these blue shapes here on the side. But there is a lot of blue apparently everywhere. Let's see just how blue those things are. So I'm going to draw these tiny rectangles as transparent. According to the blueness, they will be more opaque if they're bluer than others. So we can do that easily here by saying the global alpha, before drawing each rectangle, we set it to the point blueness. But this is a value between 0 and 255, basically. Like if red and green are both 0 and blue is 255, then that's the maximum value we can get here. So I'm going to divide by that. And if we save and refresh, then this visualization is a little bit nicer. You can see now that my wristband does show there, but my hand is kind of disappears. And the marker here is really readable, kind of. Like you can get almost all the details here that are blue. Not all the details, like here where it says this beak and there is the yellow and it's nothing there. So really what we're displaying here are those pixels that are somewhat blue. And this part here seems to be the bluest because it's now the darkest colored one. So I thought the cap is the bluest, but this is more blue apparently. Great, but now that we have this data here, I really like to visualize it as in a chart. So let's make a simple chart with it, and I'm gonna make it here at the bottom of this canvas. Maybe if I close this, there will be enough space to show it here. So this height, I want to add to it to make space for the canvas, and I want to show the blueness of each point on an axis there. So let's add 255, since that's how much blueness we can measure. And here, let's begin by resetting the global alpha to 1. And let's translate at the bottom of this image data height. So I'm going to translate 0 horizontally and vertically by that value. And now let's loop through those points one by one, like this. And the value of y is going to be the point of I blueness, like this. And on x, we just use all the possible values, so depending on the canvas size. Let's say x is equal to the canvas width. We use that by multiplying it to I divided by how many points we have. So this here gives us a percent, and at that percent of the width, we are gonna draw a new point. We do that again with this fill rect method and a small point again. So at x and y, 1 and 1. Now if we save and refresh, we get this crazy thing here. And the image is a little bit laggy now because of drawing all these points there again. But that's fine, it's just for debugging. And this crazy thing, what we see here, is basically saying that there is some serious amount of blue here at some point. Like if I remove this marker from the image, that part goes away. And it's happening here on this side of the graph just because this is kind of in the bottom part of the screen now, and if I go top part, then I'm moving it to the beginning. It's a little bit crazy. X here doesn't help us very much. So we could get something more meaningful if we sort these by the amount of blueness. Before we draw them here, let's call points.sort depending on this blueness value. And now we can get this kind of more recognizable line chart here. So the higher values are here at the beginning and they are going down. And interestingly, they form these kind of knee points, these kind of bends here. Now, these happen probably because my wristband is here. So you can see how this one knee point here changed a little bit. It goes lower faster because those pixels here just disappeared. And of course, this main part here is for the really, really blue pixels. Like, if we take this out, then there is no blue really. My wristband doesn't seem to be that blue in this lighting. But this, definitely, it makes the chart change a lot. Now, we are really interested in figuring out what are the pixels belonging to this blue marker here. And those are the ones with this blueness, kind of. And we will use a threshold for that. So we won't be interested in these pixels that are just a little bit blue in this case. You could theoretically work with all of them and maybe do some kind of weighted averaging, but I'm not going to go into that today. Instead, here, just this threshold value. And this threshold, we will set it here in the constructor. So I'm going to define it as an input element. And it's going to be a range, so a slider. Starting at 0, what we had before. And maximum, I want full control, so all the way to 255. And let's give it a starting value. Maybe 25 is a good choice, let's say. We also should see it, so I'm going to copy this and say that we want to append this threshold. Let's save, refresh, and now you can see here this looks very different, but that's because this threshold is set so low. So if I'm going to set this as it was previously, the line chart looks as before, so at 0. But then if the threshold increases, we are focusing on just the bluest of the blue items. So now my wristband is gone from there. All you can see is the blue information on this marker, pretty much. Let's see what this value is. I'm going to right click on it and inspect, turning on the developer tools, and let's set this as a global variable, this temp1. I'm going to type here temp1.value, and seems like 37 is a good choice. I'm just gonna put 40 or so here as the default, so I don't have to change the slider all the time. Save and refresh. And now this looks pretty good here. But what we want to find is really this blue item there. So where is it exactly? We can define it by its center point. And that's what we are going to get by averaging all these points that we have here. Let's implement a helper function first, this private method called average points. And the center, let's initialize it with 0, 0, and now loop through all the points like so, and add to the x the point x, and to the y the point y. When we're done adding everything, we have to divide by the point's length, both of these. So that gives us the average. And let's return this center. Now we can use this function, for example, here, after we have the points. Let's use a variable called centroid. That's usually the proper term when talking about clusters. and averaging the points like this. And now we can display this centroid. Let's do it here in the debugging section before we do this translation so that we don't draw them in the chart section. And I'm going to begin the path and do an arc this time at the centroid location. Let's give it a radius, maybe 100, and a full circle, so 0 to 360 degrees or 2 pi radians. And let's stroke so we don't cover the object. Now if we save and refresh the page, we can see that the marker cap is surrounded in that circle now. And this seems to be really good. Like, if all we want to do is figure out where the marker cap is, we're done. But we are not ready. I'm going to show you also how to figure out the size of this marker. It's going to be useful later. And we're going to also need to figure out how to have two markers. And that's not obvious. Like, if I'm going to add here the other cap, this doesn't work anymore. It shows that the location is in the middle of the two, and that's not correct. But let's figure out the size of this first. And for that, I like to use the square root function. So the square root of the number of points kind of gives us size measurement. And here, the radius is going to be the size divided by 2. This is what we're going to use when drawing the centroid now. Save and refresh. And you can see that this circle is smaller now. It's not exactly like the size of that thing, but if that would be a square shape, then it would be the same size, assuming you also draw a square with the half width of that radius. So anyway, if this is circular, like if I'm holding this like so, it's a really good estimation for circles as well. And we are essentially counting the number of pixels that are blue there and taking the square root because I don't want to work with surface area of that thing, just the size. And I hope that makes sense for you. Anyway, let's figure out how to do the other one as well. We're going to divide these points into two groups. One is going to be all the points closest to this first point. Let's just use the very first point in the array. And the other group will be the closest points to the last point, like this. So to get group 1, we can use points.filter. And here, the point that the distance to the first is less than the distance to the last. This distance is a utility function, and I'm just going to add it in index.html here at the top. Let's say distance between P1 and P2 is the hypotenuse of the difference on x and the difference on y, basically using the Pythagorean theorem. And now back here, when defining the centroid, let's call this centroid 1, size 1, radius 1. And here, instead of points, we use group 1 and group 1 length. These values here also need the 1 now. Save and refresh. And look at that. We have this one marker cap that is the only one highlighted there. And it kind of works, but if it becomes lower than the other one, then it changes. It bounces to the other one. I think it's clearer if we emphasize what are the points in group 1 and group 2 when we have it as well. So here where we are drawing these points, let's just draw group 1 and let's give this a color red and make group 2 in the same way. So I'm going to copy here this with group 2. This one becomes greater or equal to. And let's copy here centroid 1 and have centroid 2 with group 2. And these values as well. Size 2, radius 2, size 2, group 2. And we're not drawing centroid 2 at the moment. So here I'm going to copy this with centroid 2 to radius 2. And we also need to draw group 2. So I'm going to copy this. And let's say this is going to be yellow, group 2. Save and refresh. And this is what we get now. The chart also turned to yellow, but we don't need to worry about that anymore. So what happens now when this goes higher? Actually, when this goes higher, this is red. And when this is lower, this is yellow. And there is some crazy thing happening. If this is both lower and higher, if that makes any sense. So somehow this top part is less than this, and this bottom part is more than that. It's normal. It should happen like this because now our first point is here and the last point is here. So this decision boundary is in the middle between those. It's normal that it behaves like this, but we don't want it. So we're going to fix it next by implementing a kind of stabilization process. We're going to replace here these first and last with centroid 1 and centroid 2 and repeat this step where we are finding the groups and averaging the points several times. This is essentially the averaging step in the k-means clustering algorithm, and I might talk about that if I do a phase 3 for the machine learning course. But for now, let's just see how it works. I'm going to have centroid 1 and centroid 2. And these groups, I'm going to define them as empty here because we will need to update them as well. That means we remove the const for both of these. And this is the loop. I'm going to do a fixed number of iterations here, maybe 10. And in each iteration, we get the groups and update the centroids. And get the groups and update the centroids, and so on. I forgot to change here first with centroid 1 and last with centroid 2. Save and refresh. And now you can see that even if I block this, sometimes the colors change. It depends on what is the initial centroid in each cluster. But look at those circles. Don't care about the colors. The circles are perfect. And to fix the colors so that one is always on the left and the other is always on the right, I'm just going to define a left marker and a right marker. So I'm going to go down here at the end of the debugging section this time. And let's say marker 1 is going to be, I'm also going to group the centroid, the points, and the radius in marker 1 like this. And the same thing for marker 2. And now when returning, this function is going to define here the left marker. And depending on centroid 1, if it's on the left of centroid 2, then left marker is marker 1. Otherwise, marker 2. And for the right marker, it's the opposite. So I'm just going to copy this and say here marker 2 and marker 1. And we don't need any of this debugging stuff anymore. It will work. So removing everything to do with the canvas context, even that chart and sorting the points, unnecessary. And at the top here, we can even remove the canvas. We could still keep the threshold for now, but the canvas is not necessary. Or let's remove the threshold as well. Maybe we can make another display element for it. It's not good to forget it here so that this component adds it to the page. We don't have much control over things like that. So now if you save and refresh, there is nothing there, nothing fancy happening there, but all the processing is happening behind the scenes. And we can use the results of the processing now here. So let's take out the results from that. And let's debug again real quick to see if this works. So if there is a result, so if we do have some blue in the screen, then let's set the fill style to red again and looping through all the points of the result left marker points and fill each point with red, like so. And let's do the same thing again below for the right marker with yellow. And right, save, refresh, and now we have this. We pretty much always get now red on the left and yellow on the right, unless one of the marker caps is hidden and then the other one just gets sliced in half. Assuming that we are going to hold them like this all the time, then this is really stable. And no matter what I'm doing here, I don't get any kind of turbulence. If the markers are too close, then this happens again. But that's because the system doesn't really know that these are two things. It just looks at where the blue is, and now the blue is kind of clumped together. And we can tell that that's a space there, and it shouldn't be. It should separate the two items like this. But it doesn't have any idea about that. Think about it also like this kind of small circle that you see here. It's also clearly separating two things there, but we know that it's supposed to be the same object. I mean, if you look close enough, that black there, it's just black because it's dark, it's a shadow. So working with that kind of stuff, trying to teach the system that here there is a clear separator between the things, may give you unwanted results. And keeping it simple like this is normally better. You just need to keep the markers a certain distance away from each other. And if you do that, then this is a really reliable system. So, and fast. Now it's a little bit slow because we're doing that debugging, but if we don't care about that debugging, it's really fast. Okay.